Let me introduce you to my Warco drill press. But could it be improved? Okay, welcome back to the workshop. So in the last video we got the brake system finally sorted out, we got the DRO read head aligned and working, so when we move the knee up and down we get a readout on the DRO now, very pleased with that. And then we started to have a look at the XY table and the ball screw conversion and what was involved. So we got all the parts over on the workbench, so let's head over there now. I'm just going to finish my coffee and I'll see you over there. Okay, so now we're going to make the ball nut holder. So this is the ball nut that goes on the long x-axis of the table, and this is the part, yeah, it goes into there like that. We're only going to use these two center fixings because if you remember in the last video, we're going to grind this top off so it's flush with the barrel, the main body there. So we'll only be able to use these two fixings here because we can't afford that extra height there at the top or bottom. So that will fit into there, and so we've got a profile to cut. Got drill and tap the two M5 fixings there, and then in the top view we've got these countersunk holes, all these I think actually I was going to do a counter bore, yeah, so there'll be a flat area for the bolt head to sit on at the back of the part there to hold it in place. Now you'll notice it's very thin here, there's very little material left, and clearance, even this is chopped away where the main table that's above just about fits around. But I think it's going to be okay because we've basically got a bolt here, which is this one, and then a bolt on the front face, so it's like two local brackets that just happen to be joined by a little piece of aluminium, so there shouldn't be too much stress there. Right, let's go over to the CNC machine and have a look at that being cut out, and then we'll counterbore these holes on the drill press. Due to a technical error, I haven't managed to film just cutting the profile out, so we'll cut straight to the drill press where we're going to drill and counterbore these holes. Okay, I was just wondering how I was going to do the counterbores here because they're not very easy to do in the cordless drill. You need to apply quite a lot of downward pressure and turn them quite slowly, so they're really biting into the aluminium and cutting that way. And I thought, hang on a minute, I mean technically this is available to drill some holes. I know I haven't got the XY table finished yet, but why not? So it was quite nice just to be able to dial in and move the height up and down, get that just so. I've got my old vise clamped here, got it all lined up, clamped it down, and yeah, we've got the keyless chuck. This is the new one. We'll see how we get on with that. So we'll set the speed and let's see how we get on. Oh wow, that was nice and quiet. Interesting looking through the camera, it looks like it's going backwards very slowly, but I assure you it is going clockwise. Right, let's bore this out. I was going to set the depth stop, but I haven't made that bit yet, so I'll just do it by eye. A bit fast. bit further. depth, so I'd want to move that out of the way, but that's not very easy. However, I can now, I loosen the clamp and wind it down. Check our depth, let's try that. Yeah, looks pretty good. I'll do that one. Lower it down. Yeah, perfect. Right, so we need to clean this up, and then we've got to put the chamfers on just to give it some extra clearance. So let's go and do that next. And after a bit more machining, it looks like that. So I had to take quite a lot of the corners off here because I gave it a little trial fit, and it was very close, so just took a little bit more off. I don't want to go down any further because you can see there's very little metal left if you're not careful just in that corner. The lower you go down, the more you're going to get close to that radius there. There's a fair bit of aluminium at the front there, so I think we'll be okay overall, and it's hopefully it will clear. Now the other thing I did just to give me a bit more clearance is went to this button head style. They drop in like that, and then that goes onto here. So I designed it to fit on the original holes that the original ball nut goes on, or the lead screw nut. Somewhere in there. So the idea is that there'll be a ball nut like this one that will go into that housing. Now clearly that's never going to fit like that, so what I need to do is remove the top there and remove the bottom piece, so you'll just end up with basically two little wings like that that just bolt into those there. I did think about machining a relief in this, but wasn't really much point. You're not going to win anything that way. If you're going to grind one side, may as well grind the other, and then that will go into there. So that's all okay. So you can see it's all very close and all very tight. There's very little material left. I think it's going to work. Right, let's offer up the table. So it is clearing, but no, it's catching on something. Yeah, you can see there on the sand casting, so it's okay to that point, but then it's starting to catch on there. That's quite raised all the way across there. Okay, you can see where this surface rises up there. So not only have we got to take about 1 millimetre off here, whatever we get down to, we've got to machine that all the way to that same level to give us the clearance from that ball screw. But I think we'll save that job till a bit later. So right now we've got the y-axis, the small piece of the saddle, if you like, moves backwards and forward like that. So over on the CNC machine, and we're ready to drill some holes, so I'll join you over there. Okay, so I've got the part clamped down on the table, and I've just got it dialed in across that edge there, and it's reasonably true. I think it's just moving around with the surface finish on there. So we've got that true, so now we can pick up off that edge as one datum, and then this other edge down here is another datum just to get to the position for our 4 holes. So we'll touch off those and then I'll bring you back and we'll drill the holes. Okay, so we've got the part on the CNC machine and I've got it squared up, running the dial indicator along this edge here. Picked up off these 2 surfaces, and with a 3mm twist drill I've just drilled out the 4 holes. Now, I was focusing so much on getting that right and I nearly messed up and got the hole in the wrong place by quite an amount, which would have basically been a bit interesting to recover from. So I was focusing so hard I forgot to actually record that bit. So basically I've just peck drilled, just manually moving using MDI over to the 4 locations and double, triple checked and then drilled each hole. So they're 3mm, so I'm just using the cordless now to open it out to 5, because this thing's got no torque, and as soon as you put any kind of large drill in there, it's a high-speed spindle. You either burn the bit up running it too fast in this cast iron, or if you run it slow it just stalls. So it's done its job, it's marked out the holes, so we'll just open those out now. So I've got one more to do, and then that should be it on this part. Hopefully they'll be in the right place. Through. I'll just clean that up. And just deburr those. Let's see if we can do this. This will be a nice check. Right, where is that hole? There we go. Right, now because the ball screw comes through here, I'm just going to use these low profile button head ones. These might be too long, I'm not sure, but the main thing is I just want to see if they're all going to go in. That means I've got the hole spacing right. Now it doesn't mean it's in the correct location, because it's going to be dictated to a little bit by the ball nut underneath, but this will be the first check. Yeah, I think we're okay. Yeah, so these are M5s, and the hole actually drilled out to, I think I said 5 earlier, but they're actually 5.5, just give me a little bit of adjustment. Yeah, we're going to be fine. In fact, they're a good length, so I'll probably, probably use these. They don't really need to be that long, but won't do any harm. Once you've gone past about 4 threads engagement, if it ever breaks, the rest of the threads aren't doing anything, so let's just go along for the ride. Oh, looks good. Right, so we'll trial assembly this, because we need to work out the distance between the lower surface and the piece of the casting on the other side, so because we need to machine a bit more away. So let's take you over there next. Actually, I need to take that off. It's not going to go on there, is it? So I'll take that off and then we'll start the measurement. So, I think, as a lot of people have said about these import products, they are essentially a kit that you can do things with and tailor them to your own needs and level of accuracy. Right, So we won't put the gib in. So the gib's on this left side, so we know ultimately it's got to be across there. Gently put that on. Okay. So we're mainly rubbing across the top surface, which is not a reference, so that's okay. Right, now as you'll see, there's no way that will... oh, it does fit. Okay. It fits there. At the back. Okay. Okay, so it doesn't need that much taken off at all. So I've actually put it underneath so it's in line. Yeah. Yeah, maybe take... so the surface I need to machine is this one here. Yeah, that's one. So if we take it 1.5, let's say 2, I think we'll be fine. Right, let's go do that. Okay, so we've got it clamped down in a couple of places, so I think with the light cut we're going to take, that'll be fine. So basically we need to take 2mm off this surface here. Now to do that I've got a very long end mill sticking out the collet there. So it's not going to be the most rigid setup, but that's all I can do to reach all the way down into that pocket, because I've got to get right up to the edge to make sure we've got clearance across most of the width. Right, so let's touch off, get our part depth set, and then we'll just manually machine that out. Oh, just... this is loose. Wow. Unless we get to sort that out. Alright, back in a minute. Well, I've just come out here to do another session and just finish off machining the floor there. You can just see I've just got down to final depth, just need to neaten it up, and the computer's misbehaving. It's just gone round in an endless Windows startup loop. It never quite gets to XP, and then it just falls over and then it boots up again. This is the ancient PC in question. It's coming up with a N4DISP.dll error, which is the graphics driver. So it could be the graphics driver, it could be the graphics card itself has finally had it. I don't know, but for whatever reason it's not booting up. I've been having trouble with it over the past week or two, getting worse and worse, and not quite booting up and then just about making it. But now I think it's finally had it. Okay, so here's the graphics card, as you can see, based on the 5200 chipset. It's pretty ancient now. Yeah, but it did its job, it's got me this far. So I assume there's something wrong with the hardware on here. Or it's maybe the capacitors are dried out, but if you look closely, nothing looks too domed. So I could desolder them all, and guess I could check them all. There's quite a few to check there. I did price up some new capacitors. It was about £10 or £12. Plus and then a little bit of a fiddle to get off because you've just got the 2 pins, so I'd probably end up just cutting them open and then pulling the pins out one at a time, at least to get them off. Yeah, could do that, but what I decided to do is just take a chance, and I found this used one, and apparently in working order, but basically exactly the same. So nothing to lose really. We'll give this a go. I think this was £18. Which I thought would be a little bit less than that, but that's what they wanted for it, so that's what we got. Now it is exactly the same spec, and it's the same model on there. So it's the 5200 FX chipset, and it's the NVIDIA version of that. So exactly the same memory, as close as I could get. Basically exactly the same model name. I think the outputs, yep, the outputs were the same. So we've got the old VGA, which is what I need for the old monitor, and then the S-Video as well, which I don't need. So we'll drop this in and see what happens. I guess we've got nothing to lose. If this doesn't work, I've got some ideas, but more on that in a bit. Let's pop this in and see what happens. Alright, I can't even get it to see the CD. There's no keyboard. I've had it. I think it's the end of this system. So now I'm in the middle of a job at the moment. It's technically, I've machined everything that I need to. I was just tidying it up and making it look nice cosmetically, but there's enough clearance, so I can either take it off the CNC machine and, you know, it'll work. It just won't look very pretty because it's have like machining marks in it. And then when I do finally get this machine up and running again, I can drop it back on there. I'll have to obviously centralize it and pick up off the edges and just machine it nicely, but it would mean I can carry on with the build and I can get some of the later steps done. The other option is I can leave that on the machine until I do manage to get this all working again, which could be, well, it could be many weeks away. It could be a month or two away by the time, you know, rewire all this and do it as I really want to get it sorted out. Okay, I think I've made my decision. I'm going to leave that part on the CNC machine. It might be there a couple of weeks. Yeah, we'll make as many of the other parts as we can. There's a little bit of lathe work to do, so we can get that done. I was going to wait till later in the build to do those bits, but may as well get those bits done now. So it'll all be a little bit out of sequence, but I want to progress it. I think, well, I definitely know this is all, a lot of this is going to come out now. We'll get an Ethernet motion control system on here. I'll need a new PC. There are some small form factor mini PCs that you can actually put directly in here that's sort of this sort of size, so that's an option. But my wife's got a couple of PCs, and one of those, just a tower one, just to replace the one that's under the bench. You know, I could kind of do that for free and save yourself a bit of money, so I'll probably do that. It's got Ethernet out, so that's not a problem. So it just comes down to what we're going to do in here. So I think effectively that little cheap breakout board will go. That, in fact, was free. It came with the drivers. Although that did work fine, I've had to make a few sort of modifications to make this whole thing work. So if you see these relays here, these are I had to put those in to prevent false e-stops, particularly on the long run to the z-axis. These wires act like antenna, and had those relays in there on the limits so that the wire room's quite short. The control fuses, I think I can get rid of those, which run for the 24 volt system. There's a 5 amp fuse on there, and the driver fuses, which are here, and those are just the common power supplies that bring the 0 volts all the way down through to the drivers. So I think I can clear all that out. I can probably crop off the end of this conduit here to leave me basically all that space to put some kind of Ethernet motion control system and maybe a breakout board optionally, and possibly I've got a little bit of space down here that I can use as well. And I think I'll reconfigure this area up here so the main 72 volts comes in. It will go through some kind of DIN rail mounted fuse system, maybe one for the whole system, so like a 10 amp fuse for all the drivers, not quite sure. Then it'll go into distribution blocks for the plus and minus, and they'll run down this conduit down here, and then there'll be a purpose-made harness that will come out to the power over here. Step and direction will come from something to do with the motion control and make up some nice neat cables that come to each of these, and then the stepper motors already coming from the bottom towards the bottom of these drivers here. So I think that's the plan in terms of master 24 volt switch. I think I'll keep the master relay and the spindle relay and those distribution boards there, if you like. and at the top probably keep that. I might move it along a little bit, but basically that all works. Now, depending on which of the motion control boards I go for, I'll definitely need the 24 volt because that will need to run all proximity and the main interface board, and then that little one just there, that's 5 volts. So depending on which one I go for, I may still also need that. The MCBs, I'll keep those. The contactor that runs the main power supply, I'll keep that. All the star earths in there, I'll keep those. And then we'll just see how we do for space. I may change this around a little bit, but try and keep what's working, and then sort of put everything together in a more logical place to give me some space to put these breakout boards. Now, although it's not strictly necessary, this panel here just kind of screws on, and then behind here there's just kind of wires, and the harnesses go up here, and it's kind of just joined straight into the back. And I always wanted to hinge this because some of the professional panels have hinges and a sort of lock system, so you bring this down and then you can easily work on the back. You have plug-in connectors and it's nice and neat, and then you just hinge it back up and clip it in place. So I might do that just for neatness and just keep in the, because the bottom of this is not that tidy, and I think I could make a better job of that, especially if I end up utilising some of these extra things here. Yeah, lots of options. I might even put a USB outlet there, so you can just plug the stick drive straight into that and it just has a feed down to the computer. A couple of different options there, but anything to do with this I think I'll carry on in the CNC build series, which is about episode 26 or 27. So anything I do to this will be in that video series, and then I'll make very slow progress in the drill press, which is this series, until this is up and running, and then I can use this to make more parts. Okay, so in a little bit of a different build order than I was planning, let's make some progress at least. So earlier in this video we made the little block that goes on there, it goes on that way around, so I won't put that on fully. And then this is the ball screw. This is the one I got off BST Automation on AliExpress. It goes, I think, yeah, I need to turn this, okay, so I need to take this off and turn it around because that's the wrong way round. So I need to flip this over, that's not a problem. I'll just make a tube that goes on here. We'll see if I've got one that go on here. I've probably got one in my box. Wind that off, turn it around. Anyway, imagine it's the other way around. And basically what could happen is, so I'll put it in, here we go. Right. So just imagine this is on that way round and that's in there, and then you start to, let's put it like that, then you start to wind this screw. So basically what you're doing is you're winding the table off these V ways around here, and you're going to go so far and eventually then all the balls are going to fall out. So I just wanted some kind of stop, but I wanted access to it such that when it was all the way over here you could get something in and sort of wind it up. I didn't want something hidden underneath that you couldn't get to and really sort of back yourself into a corner or paint yourself into a corner and you couldn't actually build it. So our plan is, that's why this is turned down to a plain 10mm shaft, is just to drill and tap a hole in the end and then make a kind of collar that goes on there, and then you put a screw in there and it locks it out and basically stops the balls coming off the end, so you can't get it off until you undo that collar. And you know, then if you really do want to take it apart, so that'll just stop it falling apart in use. So I've got the drawing over by the lathe, and we've got the part ready, or I've got the stock ready. Let's go and make that part next. Okay, it's the drawing for the stop collar, nothing too fancy, so it's made out of steel. The end of the ball screw has a 10mm plain shaft, so this is 10.05, just to give us a nice slip fit onto there. And then we've got a 5.5 hole here, so we'll have an M5 button head screw that will just sit nicely on there, goes into the end, kind of screw this in, and then the collar itself just stops the whole, it stops you being able to wind the whole ball screw out of the ball nut, because otherwise there's nothing stopping it going there, and then all the balls will fall out. What else we got there? We just got that board to 10, which is the amount that the plain part of the shaft sticks out, and then the overall's 14. So nothing too fancy. Got a bit of just cold rolled steel in the lathe. Let's turn it. now we've got the inside bore to do, so we'll take most of it out with the twist drill, but be careful not to go too far because obviously it's got a pointed end there. So we'll get most of the way down. I thought I had an 8mm end mill, or a 9mm, which would have been perfect, but turns out I don't. So we use the twist drill to get most of it out, and then we'll see if we can use the boring bar just to give us our flat bottom hole. Okay, here we go. Turn the speed down a bit. And we're zeroed here just with the tip touching, so we'll go in about 8.5, maybe 9mm. There we go. There we go. Right, that should do it. Tell you what, let's just try the ball screw in there. It should be a nice fit, otherwise we'll give it another spring pass. Okay, how are we doing? You know what? I'll take that. Lock off the carriage. .66, so take 0.66 off, and then we'll put a 1mm chamfer on there, and we're done. There it is, just our little simple locking collar. Okay, so we've got the long right hand ball screw in the lathe. I thought we'd just try it with the ball nut on because we're only going pretty slow, and I just put a centre in here, drilled it out, and we're just about to tap for M5. So this will hold that little retaining collar on that stops this being able to be wound all the way off accidentally and all the balls falling out. So we'll just tap that, and then that thread will be done. So we're just turning the chuck by hand, and then just feeding the tailstock in using the hand wheel. While we're here, we may as well just try the proper end cap. I think that'll do it. So yep, I think it's hit the seal. Yeah. Perfect, right. Another job done. Okay, and here's our part ready made. Now, the reason it's just on this nail is because I've just cleaned it with the white spirits there, so I should have got all the grease off it. And then I've just filled this, it's an aerosol lid, just with a little bit of the cold blue in the middle, just trying not to waste too much of it. I'm just going to use it neat again. You can dilute it a little bit as well if you like. So we'll just drop that in for a couple of minutes, swirl that around, then we're going to wash it off, wash it with a WD-40, and then we'll put some oil in it, and hopefully that will keep the rust at bay at least for a little while. And hopefully it won't come off the nail. I'll come back in a few minutes. Right, I think I'll call that done. Wash it off, clean it with WD-40, and then we'll get the oil on. I'm giving it a good rinse. I think I've treated the nail as well. I'm not going to use that again anyway. Yeah, just for info, that's the stuff I've been using. This Phillips Cold Blue, 250 mils. Yeah, sodium dioxide, toxic if swallowed, so do be careful. Yeah, pretty impressed with it. Alright, time for a bit of oil. Rub that in. That's what we've ended up with. Really nicely made part. Yeah, again, I'm very impressed with that. Okay, so here's the ball screw we just drilled and tapped. Obviously this has got to be turned round, so this will all just be temporary. So for now, I'll partly put it back in its bag and keep the rust at bay. And then on this end, just to stop it coming off, got a little part we made earlier and cold blued it, and then that should, oh yes, a nice drop fit onto there, and a little M5 button head screw. This has got to come off to get the ball screw off, but just nip it up for now. stuck on the seals. I think you'll feel that. If you really try, I'll probably push the seal over that, but then the balls won't come off. And you'll know you're at the end. And because that is over here, then by the time you get to this point, this extent, then the table at the top will be a long way that way, and I think the edge of it will be about here. So you should be able to get in, undo that, and if you really do want to disassemble it or run this off the end for a reason, you know, put a tube on there and run the nut off and take the table off completely, or more likely you'll probably disconnect it from the other end, but you've got options now, and at least you've got this kind of safety system in place. Right, nice. Yeah, pleased with that. Well, that brings us to a rather unexpected end for this video. A little bit of bother with the CNC machine, you know, these things happen. It's run for many years without any problems, but I think it's finally time for an upgrade. The main machine itself has been brilliant. Really pleased with it. I mean, it's overbuilt, but I just absolutely love it. Could do with a mist coolant and a spray, just so I could put the material removal rate up a little bit, but yeah, it's nice to use. But obviously the control system is had its day. So we managed to get a few jobs done anyway. We managed to machine out the bracket. We've got the end stop machined there, to stop the ball screw coming off the end there. And I got a pretty good plan about what I'm going to do here. Just need to finish off the upgrade the CNC machine to make some of the later parts. So that's kind of all we can do for now. You know, we need to get that XY table finished, but the base piece is now stuck on the CNC machine. We can make some progress with some of the other parts that I just showed you. And then later on in the build, we've got a big plate that fits on the back of here, and another plate that comes out and holds the quill with some bracketry on there. And that will hold that in a nice straight line, so it'll go up and down a straight line rather than relying on that little grub screw there just to give it some alignment, because it's not the super precise fit in that bore. And that will mean when you pick up on a hole, it should stay above that hole when you move up and down. So we've got that bit yet to make. We'll also have a piece coming out here with a depth stop, a digital readout for the depth, and some other functionality so you can hold at certain depths and things like that. So still got all that to make yet. So it's been a little bit of a bumpy build this time, but you know, that's life. That's how these things pan out sometimes. As always, thank you very much for watching, and I'll see you next time.